Hello everyone. In this video, we are going to understand FCFS scheduling in operating system. Okay. So definition is FCFS is the simplest CPU scheduling algorithm. The process that arrives first in the ready queue is executed first. It works like a queue in a real life. First come, first serve. And type is it is a non-preemptive scheduling algorithm. Once a process starts executing, it cannot be stopped until it finishes. Working processes are executed in the order of their arrival time. The CPU is allocated to the process that is waiting for the longest time. See, basically, FCFS stands for first come, first serve. Okay, so as the name suggests, the process that arrives first will be executed first. Okay, executed first. Okay, so just like a queue in real life, imagine you are like standing in a line at a movie ticket counter. So the person who comes first gets the ticket first. So the same rule is applied here for processes. Okay, so FCFS is the simplest CPU scheduling algorithm. It's like it is also a non-preemptive algorithm, which means like it is once a process starts executing, it cannot be stopped until it finishes. Okay, and see performance metrics. Waiting time WT, time a process spends waiting in the ready queue. Turnaround time, total time from submission to completion of a process. Completion time, the time at which a process finishes execution. Okay, see, basically uh, processes are like simply executed in the order of their arrival time. So whichever process has been waiting the longest in the ready queue will get the CPU next. Okay, and here is completion time CT, means the time when a process finishes its execution. And turnaround time TAT means the total time from the arrival of a process until its completion. Okay, and waiting time means the time of a process spends waiting in the ready queue before it gets the CPU. Okay, see example. Example. So now, so the see, suppose we have three processes with the following details. Okay, process P1 arrives at time 0 and needs 5 units of CPU time. Okay, then process P2 arrives at time 1 and needs 3 units. Okay, then process P3 arrives at time 2, needs 8 units. Okay, so let's see how they will execute step by step. Okay, so basically at time 0 only P1 is available, so P1 will start execution and run from 0 to 5. Okay, then P2 is already waiting since time 1, so after P1 finishes, P2 will get the CPU and run from 5 to 8. Okay, and then finally P3 arrives. P3 has been waiting since time 2, so it will start after P2 and run from 8 to 16. Okay, so the execution order is P1 first, then P2, and then P3. Okay, Now let's calculate some like important terms here. See, first one is completion time. So the time at which a process finish. For P1 completion time is 5. For P2 it is 8. Okay. And for P3 it is 16. Okay. And the turnaround time, the total time from arrival to completion. So for P1 it is 5 minutes. 5 minutes 0, which is 5. Okay. 0. Okay. And for P3 it is 16 minus 2, which is 14. Okay. And for P3 it is 60 minus 2, which is 40. Okay. Then waiting time. See, waiting time, the time a process spends waiting in the ready queue. So basically for P1 it is a turnaround time minus burst time. So 5 minus 5 equals 0. Okay. 0. Then P2 7 minus 3 equals 4. Okay. Then for process P3, 14 minus 8 equals 6. Okay. So process P1 has completion time 5, turnaround time 5, and waiting time 0. Okay. And process P2 has completion time 8, turnaround time 7, and waiting time 4. Okay. And process P3 has completion time 16, turnaround time 14, and waiting time 6. Okay. So now if we observe carefully, in FCFS the average waiting time can sometimes be very high, especially like if one process takes a lot of CPU time. So this problem is known as the Convoy effect. Okay. Convoy effect. Okay. So for example, if a very long process arrives first, all the shorter process behind it will have to wait. Okay. So in short, like FCFS is very easy to implement but not always the most efficient. Okay. See, basically FCFS is the simplest CPU scheduling algorithm. Okay. So the idea is very easy. The process that arrives first in the ready queue will be executed first. Like you can think of it just like a queue at a bus stop or a ticket counter. So whoever comes first gets served first. Okay. So FCFS is a non-preemptive scheduling algorithm. Means once a process starts running on the CPU, it will continue until it finishes. Like it cannot be stopped in between. Okay. So like processes are simply executed in the order of their arrival time. Okay. Whichever process has been waiting the longest in the ready queue will get the CPU next. Okay. See, Here is completion time means the time at which a process finish. Okay, process finish. For P1 is completion time is 5. Okay, and for P2 completion time is 8. Okay, for P3 completion time is 16. Okay, and see, turn around time. Turnaround time means the total time from arrival to completion. Okay, so for P1 it is 5 minus 0, which is 5. Okay, for P2 it is 8 minus 1, which is 7. Okay, for P3 it is 16 minus 2, which is 14. Okay, so basically process P1 has completion time 5, turnaround time 5, and waiting time 0. Process P2 has completion time 8, turnaround time 7, and waiting time is 4. And process P3 has completion time 16, turnaround time 14, and waiting time is 6. Okay. So basically average waiting time can sometimes be very like high, especially if one process takes a lot of CPU time. Okay. So this problem is known as the convoy effect. Okay, thank you.